Hi, I would like to welcome everybody to this. I'm sorry about the delay. We had some problems. We're going to start the broadcast over. I would like to first introduce Fatih Ugurdog.
Hello there, welcome everybody. So this is an IEEE Computer Society distinguished speaker talk, and our speaker is Professor Ignacio Castillo. And the title of the talk is Data Centers, the Cloud Computing Infrastructure as a Service. So I would like to say a few things about IEEE Computer Society. IEEE Computer Society is the world's leading organization for computer science and engineering professionals. And I'm the Turkey chapter chair of IEEE Computer Society. We actually wanted to bring Ignacio over to Turkey, but then later Kerry suggested that we do a talk online, so I welcomed it, and hopefully we'll bring Ignacio over to Turkey later on. As the chair of IEEE Computer Society Turkey, we try to boost the number of distinguished speaker talks like this one, and we try to organize as many local conferences as possible on computer science and engineering, and we try to introduce different fields such as this one to especially young professionals and students. So I want to hand the microphone over to Ignacio now.
Well, Dr. Fatih, thank you very much for you and the Turkey chapter of IEEE Computer Society. Carrie, thank you very much for hosting us. Well, this talk deals about data centers, the cloud computing infrastructure as a service. Well, the three parts we will offer is cloud computing, a general view, and after we will center on data centers and some spatial applications. At the end, we will center on certifications for data centers. Well, due to this is a virtual talk, and in order people do not sleep so fast, I will run two videos. After the part one, I will run a short video, and after part two, I will show you a short video about real data centers. Well, let's begin. About cloud computing, we call cloud computing the fourth way of computing. So here is the slide I did. I'm again 2011 and 12, using the IEEE initiatives, the IEEE Smart Cities, Internet of Things, Cloud Computing, Big Data, Smart Grid, cybersecurity, and well, we will be talking a bit about cloud computing. Well, we call cloud computing the fourth wave of computing. Maybe in past we will remember that everybody was talking about ISP, Internet Service Provider, but also in time people changed this terminology. The description was changed to Communication Service Provider, and now we also can use the same letters but having a different meaning, Cloud Service Provider. In past, we moved from mainframes in ARPANET era, after we moved to the client-server architecture, and after to the web, and after virtualization. But around 2000, something very interesting happened, and people changed it to the cloud. But well, how was it defined, or why do we move from virtualization to cloud? Well, virtualization, maybe everybody can remember in 80s and 90s, virtualization was applied to RAM, disk drives, computers, servers. Specifically in the United States in 1998, VMware company applied successfully the server virtualization, specifically under the Intel's 86 architecture. But after, people say, hey, we can virtualize this. Why don't we virtualize switches and routers? And after, people were beginning to think about virtualizing humans using biosciences and new materials. Well, the idea was the virtualization of everything as the Internet of Things, Internet of People, and now the Internet of everything. Well, maybe also we can remember in past that a lot of people were talking about software and hardware as separate entities. But while the computer definition was getting better and better, we can define a computer as what? As a multi-level machine, using always the real machine, and above the real machine, we have many as we can virtual machines. So in this case, this idea about virtualization or doing it in a way outsourcing is not new. In time, we have had hospital as a service, restaurant as a service, school, transportation, army as a service, government as a service, economy as a service, security as a service, and then it was moved to the everything as a service. Use it that XaaS, everything as a service. So in the computer resources, it was also applied. But how any technology in past, in present, and in future is under a specific behavior? Well, Gartner's, the consultant company, try to check technology trends. They show a pattern, what they call the hype cycle of Gartner's. They show at this side the visibility and in time the maturity that you can reach after 5 states. You begin with the trigger of a specific technology, the peak of inflated expectations, the disillusion. But what we really wish is the plateau of productivity, this zone. And for example, let's see, maybe we can remember that in 2001, we have a stream change around the world, but specifically in 2002, it was for computer, not only for computer society, for computing around the world, a huge crisis. .com companies fell down. So cloud computing seems to be, in that moment, the way to recover all those .com companies and to make a change in the computing way to offer the service. So we can see that in 2007, we had a global economic crisis. But check, what happened in 2008? Well, we see after 2002, the trigger of this technology, cloud computing. In 2008, we were almost crossing the umbral from the technology trigger zone or phase to the peak of inflated expectations. Well, it was 2008. And well, what kind of traditional models we were having in that age? Well, the software as a service, platform as a service, and infrastructure as a service as delivery models. We had, maybe you remember Google and some Google applications, the beta in 2004, but it was completely released in 2009. We had some other very common applications, not only in West and East. We have also China moving very fast. Alibaba in 2009, it was very mature. The WhatsApp with the web chat in China, and this case, YouTube in 2005, and Youku, the equivalent in China. On the Arabic side, it was very popular around the world. The Maktub portal, which one? It was bought by Yahoo in 2009. But talking about platform as a service, we have the development kits for testing, source code management, and but specifically in this case today, we will center on infrastructure as a service. Yes, we are talking about network technology, servers, storage, virtualization, and mainly on data centers. And now talking about virtualization, once everything or almost everything was under virtualization, we also are moving under the data center virtualization. We have also a deployment model, mainly for deployment models, public, private, hybrid, and community. But let's put it all together. Since 2000 till 2011, hundreds of authors were discussing what is cloud computing, because if you can read a number of papers, everybody was offering their own definition. Okay, so in 2011, the National Institute for Standardization in Technology in the United States offered this huge conclusion after almost 11 years of fighting for standardizing a concept. So cloud computing is basically an IT model for providing computer resources on demand and low cost. Those two characteristics, very, very interesting. On demand and low cost. Well, my easy definition, in many cases, I say, well, okay, yes. Cloud computing is an outsourcing applied to computers and related technology. Three other important things happened in that year. Intel added in 2011 sensors, specifically sensors of for temperature to Xeon processors. You know, it was to aid data center cooling. You know, these processors got a size of 32 nanometers. Also, I remember in 2011, inside IEEE, we pushed the IEEE Cloud Computing Initiative. Now, it's not an initiative anymore, a new initiative. This is a very stable project. Also, maybe we can remember 2011, the Fukushima disaster. They moved a complete platform using infrastructure as a service, platform as a service, but also the software as a service. This held 2.0 Fukushima. If you have the chance, you could access using this link. But also in 2012, we passed it more than 2 exabytes. So we entered definitively to the exabyte era. And here we have the cloud reference architecture. As you can see, it's divided in 3 different colors. What users see, the user, the front end, the network. In blue, we have the cloud-specific infrastructure, checking the software as a service, you know, the cloud web applications. Also, the combination of platform as a service and infrastructure as a service. But check this, we have the storage communication and the IT computational resources. On the other side, we see the kernel hardware facilities. But please check from the right to the left. We have the provider. Now, who will support the IT infrastructure? The provider also, yes. But also we have another dimension, the authentication mechanism, the management access, and the services and some applications. So it was the cloud reference architecture. This model could be studied even from you said, for determining what kind of view do you want from cloud computing. Well, and this is what we were talking about when we used the cloud computing initiative pushed by IEEE. They moved with many conferences and publications, and the first magazine was this, IEEE Cloud Computing, the essential issue. No? Well, maybe some of you can remember, after they moved, 2 years after, they moved to having transactions. Also, if you wish to know more about the IEEE Cloud Computing, you can get to cloudcomputing.ieee.org. In this case, for example, they were dealing about the platform as a service and cloud. Well, but as you know, IEEE together with the NIST, we're moving to work with 2 standards. The P is because it was in the face of the project. Maybe we can remember that in past, in order to make a portability and interoperability between computers, the standards must be developed. And after, what happened? Okay, the same effect happened with networks. Networks in past never were talking each other, but right now we have enough standards in order they can communicate each other. So what's next? If the next step is cloud computing, then we need portability and interoperability for the cloud, but also interoperability and federation interclouds when we change not only inside a country, but among many countries. So they have, in this case, some considerations conducted by the IEEE Standards Association directed to the cloud computing initiative. So we were talking about the combination of governments, industry, and universities and other partners in order to offer protocols, practices, and the best governance using a test bed with contributions with people from around the world. Well, if you wish more information, you have to access to these two standards. Well, let's see what happened in 2014. What happened with cloud computing? So we as we can remember, we moved it in 2002 from the innovation trigger till 2008. It passed, and whoa, in 2014 we have the cloud computing in this part, the disillusionment. Why? Well, we will see it in a few slides. But also check if we are moving almost to the plateau of productivity and other kind of cloud computing, whereas moving also the hybrid, this delivery model. But also the huge, what was pushing infrastructure as a service, data centers, and cloud computing? Well, as we know, cloud computing lives inside data centers. And big data was the element pushing definitively the cloud computing. And let's see what happened in 2015. Well, check this. We cannot find alone anymore in 2015 the cloud computing. So we see what? The hybrid cloud computing. Also, this year was where the Internet of Things got over the top. And now we can see at this, I've left, check this indication, micro data centers. We will talk briefly about micro data centers. What is it? Well, we also saw IoT platforms, the brain-computer interface, and quantum computing. Maybe you can remember in 2002 and 2003, Chinese were almost the pioneers in using the quantum computing and also in satellites. But well, we had something very interesting in April 2015 when the Samsung Galaxy smartphone XC was connected directly to the IBM Watson supercomputer using big data to offer services in order to add value to the medical care. So what's next? Well, in 2015, okay, again, you can see moving forward micro data centers. Also, we have another kind of cloud computing. What? The data broker platform as a service. So it happens when you cross to the plateau of productivity and you try to check any technology as an emergent technology. So new versions of that technology arise from the left to the right. But well, let me share with you some very famous migrations. What happened, for example, with Netflix? Netflix was a very successful company in December 2006 in 2007. Sorry, they had offering a lot of streaming hours, so their sites were not enough for offering this growth in their sales. So check, this is an exponential growth, more than 1,000 times in almost 10 years. So they began the migration to the Amazon Web Services. They made a service level agreement, and they began the migration in 2008, and they ended the migration in January 2016. So since that year, they are completely in cloud servers. They got to Amazon Web Service as cloud service provider, and they offered 4 nines of availability as a service level agreement. That means more or less 42 minutes. Okay, but remember, everybody, this is the theory. in real, sometimes it's not fitted. But well, this is a great news. This is a very typical, famous migration and application. Well, let's see why it's very important for this year. Let me share with you this public cloud service revenue forecast. Remember, this is a forecast of based on $1 million shared by Gartner. Gartner, you know, that company I have been talking about. It uses this forecast, you know, till 2021. It's maybe tomorrow, no? So check. We have another kind of delivery system, the business process as a service. Maybe it will move, check, platform as a service, software as a service, security and management services. Maybe some of them are moving from 1.5 and 2 points. That means double, a growth of double. But check this. When we are talking about infrastructure as a service, we move more than twice, almost 3 times. So it's expected, you know, it's a forecast that infrastructure as a service will be the industry that which will grow much more than before. But well, let's see. If everything seems to be incredible, fantastic for cloud computing, why do not everybody moves to the cloud? So let's see. We have some cloud computing inhibitors. We have the, you know, skills and people, the regulatory compliance, the performance, integration, and maturity. But the winner is security and privacy. So this is the main problem, security and privacy. You know, many people, even the Arduinos, now at universities and in some companies, everybody's moving to, you know, Arduinos, the IBM and Intel applications and European applications, Asian applications, everybody's moving to the cloud. The Internet of Things moving to the cloud. But if we remember, we had also in 2012 and 13, this surveillance systems in United Kingdom mainly and United States. So since 2013, we talk about the post-Snowden area. So this is a stop in the migration, a huge migration to the cloud. Also, the Germany government in 2013, after all this event, declared that they were working under the data sovereignty. And what is important? The most important thing for this is to build your own data center. I hope everything is okay till this moment. And we will move to the part 2, data centers. Where is the cloud? All this cloud is supported by data centers. Then we will check now in all this environment, all this ecosystem for technology. We will move to the data center specifically. Please enjoy the video. I hope it could offer a better idea. This is supposedly the hugest data center around the world. Let me know if we have a problem. Let's check the bandwidth. They center physically on this data center. As we can see, 3 different sources of energy. The amount of energy is really huge. the quantity of energy required for huge data centers. You know, we can have football stadiums, and in many occasions, football stadiums are really small compared with the area used by the hugest data centers. In this case, we have water cooling. There is also free cooling and many other systems for having the cooling, because the high quantity of heat released from that amount of devices on systems. So as you can see, this kind of technology and industry implies what in past was covered by chemical industries, mainly the oil industry. Well, this is only for having a general idea. But well, sorry, Dr. Fatih and Carrie, are we connected? Everything is okay?
Yes, everything is good.
Okay, I hope also
Yes.
the speed is okay. Thank you very much
Yes.
for both. Okay, let's get into data centers. Are all data centers equal? No, we have many kinds of data centers. We have the enterprise data centers. This is intended or located mainly for, we can see, armies, governments, and mainly, you know, companies. That means a bank has a specific data center for their own proposals. So they are the owners of their own data centers. We were talking about enterprise. Also, we can talk about exclusively on cloud services. But I will center in this occasion on colocation, what we call colocation data centers, or simply, you know, colo. Everybody say, hey, what about your colo? The contraction of the colocation. What is a colocation data center? The colocation data center is that data center that offers services to small and medium companies, which also offer services for everybody, almost everybody, and not only companies, small and medium companies. But in some occasions, they can offer services for, you know, universities or even governments. But well, let's see. In this case, I'm showing you a worldwide map of cloud servers now around the world. As you can see, a huge quantity center in Europe, and the other side in the United States. But well, let's move to the data centers for colo, the colocation. Again, the density numbers, again, Europe and United States. Let's see. There is a specific map around the world. You know, this growth, even today, 2011, we have in this database more than 4,000 data centers for colo around the world in 121 countries with this kind of distribution. So let's see what happened around the world. You know, in the abstract, I was trying to outline how is moving it around the world in data centers, but specifically in colo, no? How is it, the map and countries around the world? Well, let's center in America. Let's see United States, the region of the United States, till yesterday, 1,724 in the 49 states. We are not considering the Puerto Rico and Hawaii. So California, as the British said, you know, the British are very, they commonly use what they call the short list 5. In this case, I only use a short list of 3: California, Texas, and New York, where the huge amount of these colo data centers are. What about Canada? Canada has 165 centered on Toronto, Montreal, and Vancouver. No, you know, very close to the border with the United States. What about Mexico? Mexico 11. Obviously, we are not talking about all. We are talking about the registered and some of colo. Obviously, as in any country, we are not considering the enterprise data centers, which are under the control and the ownership of all banks. Here we have, for the rest of America, South America, Brazil, Argentina, Chile, and Colombia. And well, what about Europe? In Europe, most of them are centered on British. Let's see, United Kingdom, 249, centered on London, Manchester, and Leeds. Germany is the second in Europe, 189, Frankfurt, Berlin, Hamburg. France, 147, Paris, and Lyon. And after it comes the Netherlands with 95, and Italy with 68. Well, you know, after is Spain with 55 and Portugal with 37. So let's see Turkey, my friends who host this talk, South Africa, Arabia, you know, Africa and Middle East, in order to move the map. Here we have, for example, Algeria 1, Angola, Congo, Egypt. But here we have Turkey. Turkey is the leader in all this region with 47. After is coming South Africa and Saudi Arabia. So in this case, yes, in some occasion when I was in Tunisia and in Lebanon, it was very funny because some friends tell me, well, yes, we are inside Africa, but we consider us as if we were in Europe. Well, we are talking about the region A, as IEEE considers now Africa and Europe. But well, we try to separate it, and we see that Turkey is a leader in the zone. We have also United Arab Emirates and Israel. So Turkey is really powerful in this zone. Let's move to specifically to Turkey. Maybe people and members in the IEEE Computer Society Turkey chapter are more involved. In Istanbul, if you are in Istanbul, you can find 28, and in Ankara 6, and Bursa 4, and in other cities, 1 or 2 of this kind of data centers distributed in this way. Obviously, we can have many others, but those data centers are registered, no, commercially and registered. Obviously, we can find maybe other data centers which have not been registered in that platform. Let's see what happened in Tunisia when I visited Tunisia. Okay, we can find this, the EU data center. This is very related with Europe, and also in Lebanon, in Beirut, just 1. The Lebanon is for advanced information. So in future, we can hope they can increase. But what about Asia? Well, the leader there is India with 140, China with 77, sorry. And you know, in China, there's another phenomenon. The information is not very easy. They do not share information as United Kingdom and USA does. No. That's the point with China. Also, Russia is reserved in the number. So we have, in Hong Kong we have 42, and in Japan we have 43. Japan is a very specific case. They have their own certifications and their own rules for data centers, but they are very, very strict. Well, and at the last but now we have Australia In Oceania, Australia has more than 100 in Melbourne, Sydney, and Brisbane, but in New Zealand, 31 in Auckland and Christchurch. They're centering that way. So I hope we can have a very well outlined view about what happened around the world with this kind of data centers. So my question right now is, okay, Ignacio, you have been talking to us about the cloud, about data centers in general, the huge one, but how is a small data center? Well, in this case, I will show you some photos about a data center of 22 square meters. The area for this small data center, maybe this is the smallest data center, below the smallest data centers, we only have what we call the sites, but you need specific rules and characteristics to call a data center. So in order to be certified, you need at least more than 20 square meters. And some elements must be considered. For example, in this hall, we can see this, the white area. In this case, for example, they try to check this and this part, the false roof and the false step zone with a dip of 60 centimeters where all the cables are moving. Well, what we have here at the left is the fire protection system under specific standards. Here we have some servers, switches, and routers, and here we have an HP enterprise rack server for storage, this disk in this case. But what about energy, the backups? No, this is a Symmetro LX APC from powered by Schneider. The backups, the UPS, the power systems, and the backup. Why? Because every data center must have redundancy in energy, redundancy in servers, redundancy in storage, in fire systems. And here we have the tools, a high-performance air conditioning system in order to maintain the temperature and humidity according to the standards. So you can imagine a square of 22 square meters. And in this data center, people is looking for a certification, what we call the Tier 2. We will see in brief about certifications and standards. What does Tier 2 means? Well, let's see. Maybe you see, okay, this is at the right, we can see the white area, and we see this window. What is through the window? Through the window, we can have the data center operation center. In this case, we have two people, two girls, watching and having the management of all this data center in order to offer services to their people. In this case, we have people in a specific university. What do we have? Well, for the highest levels, we wish this DCIM, Data Center Infrastructure Management. So they are helped and supported by monitoring systems. We will check in order to assign all the virtual machines, assign the resources, but also monitoring with sensors, everything. Well, let's see. In this case, we see they use VMware, this operations manager, indicating, the capacity. What is, in this case, they only have for a specific infrastructure, almost the 20% of the capacity to deliver the use of CPU, memory, the workload, and metrics and workload. So they monitor all the development and the operations inside the data center. But well, what happened with the rest? Okay, in this case, this provider uses a kind of watchdog using sensors for temperature, humidity, water, even level the air, the level of humidity in the air, the level of this noise, a lot of sensors, temperature. They try to monitor all the environment. How is the state of everything? So let's see. That's what we have in a small data center. So now multiply it by thousands of times when you find a huge data center. And well, let's see this other video. Another very important data center, in this case, you will see Datacenter, because this video was developed by, people in United Kingdom. People in US use center, and people in United Kingdom use center. Well, this is another interesting thing. Okay, please, everybody, don't sleep. We got another small movie.
Today, the world is inhabited by a vast amount of data, rapidly growing. The amount doubles every 18 months. By 2015, European countries will use 100 terawatts per hour on powering data centers alone. This equals the consumption of 8 million homes. And did you know that the computer industry is responsible for as much as 2% of the world's CO2 emissions? Through its natural resources, Norway is capable of producing inexpensive renewable energy. Inside a mountain, on the west coast of Norway, you will find the world's greenest data center. Operating solely on renewable energy, Green Mountain Data Center has virtually no CO2 emissions and leaves no carbon footprint. By utilizing 3 independent power connections, our center has a very high level of redundancy and resilience. The combination of Norwegian weather and geography makes the country a unique supplier of low-cost renewable energy. The Green Mountain Data Center is adjacent to a fjord that provides year-round free cooling. This reduces the center's PUE to a world-class low. Combining low consumption and low energy costs, the total cost of operation is reduced by 20 to 30%. Being a former NATO ammunition storage, the facility offers the highest level of security. We are highly protected against events such as electromagnetic pulses, flooding, or fire. Our facility space consists of a total of 21,500 square meters. The center lies next to the Norwegian oil capital of Stavanger. From here, high-capacity fiber lines connect to POPs within Norway, the UK, and continental Europe. The partners behind Green Mountain represent some of the best industrial and technological know-how in Norway. Ergo Group is a provider of ITC services and the largest of its kind in Norway. Lisa is the largest multi-utility company.
So, well, as we can see, a number of companies are around this huge data center. Well, we are almost at the end of our talk. We will enter to the certification zone.
And constant and continuous operation for the foreseeable future. Green Mountain Data Center, if nature could choose.
Well, let's move. But before we check data center for special applications. In past, when Chinese people were trying to offer specific solutions for oil industry, for example, as you can see in this picture, we have one very small. Maybe everybody remember the graph in 2015 and 16 about the micro data centers. What we can see in yellow, this yellow, now this yellow, we see a container. We have this branch, Atom. Atom is offered by a Mexican company, Kio, maybe the hugest than Telmex, the company where I work at. Maybe a lot of people know Carlos Slim, no, the company, the owner of this company of America Telecom. Well, in this case, Kio offers this data center, you know, the air openers. This is a container. Chinese people were the pioneers offering these services, and then after around the world, every company, sorry, offers this kind of data centers for oil platforms. So many companies offer this kind of platforms. You wish, for example, to make a study about oil platforms or other kind of resources, you can rent for as a service, you know, data center as a service for 1, 2, or 3 weeks or the time you need. Okay, in this case, 10 years before, I was talking about how to improve the way of making it better when cooling the servers, where just in the middle of August or November in 2015, Microsoft pushed this project and they moved a capsule with 300 servers, not deep, but 3 feet underwater for more than 100 days, and they got this experiment successful. As you can see, obviously the cooling was even better. Microsoft specifically has a bit more than 100 data centers around the world. This project was named NATIC Data Center Project if you wish to make a deeper consult about how it was developed. So in this case, they have the resources, they apply that kind of ideas. Obviously, well, we have this other application. Let's see, for example, in Puebla, Mexico, we have an international experiment, the Large Millimeter Telescope. This is a co-working between Mexico and United States, but information is also shared for around the world. It's about, you know, checking radiation from galaxies, but also measuring high energy particles. So I'm here. We were at 4,600 meters in altitude, and where, as you know, how can you make the data analysis at this altitude, even where the radiation is stronger than at the level of the sea or 2,000 meters. So this is a special case, so they need a special data center. They really have right now a site, and they are trying to move to a data center because it's very costly to move information, to take the information to be studied, analyzed in other altitude. You know, even helicopters only get to 3,000 meters, not above. No, even we are talking about the best helicopters in the world. So also we can have the data centers in space. Okay, talking about the data centers in space in future, you know, we have since 2010 we have the internet of the interplanetary. That means since 2010 we have routers around the planet, but the idea is to expand having routers moving around the moon and Mars. So it is expected that in 2040 we can have complete connectivity with Mars and the moon. But we have two choices. One choice for next generations could be building a data center in the moon or even in Mars, or the other one is having data centers in space. Yes, as if it were satellites, but really they were having or offering a pre-process for the information. So this is what it's moving for the interplanetary internet. And for the last part, we move to international standards for data centers and certifications. In this case, for example, the first one was the Uptime Institute. The headquarters is in United Kingdom, but also we have the International Computer Room Expert Association. It was born in Mexico, and it's more centered to Latin America, but also in Spain, and also in other countries. But we will see what it's deal about certifications. Specifically, I have talked to you about Kio. This company in Mexico, they have 32 data centers, 16 with Tier 4 certification and 16 with Tier 3 certifications. They are very competitive. They have a number in Mexico, but also in United States, Panama, Guatemala, the Dominican Republic, but also in Spain. So they use the uptime certifications, but also the ICREA certifications. In a practical case, for example, Kio, as a general, a general wish to have as many certifications as they can. The SAP, different operations and hosting services, ETL, SAE, the Tier 4 and 3, VMware, the best companies as a working place, Google partner, Intel partner, SAP again, LEED. LEED is a United Kingdom certification for intelligent buildings. NISA, but also CEDA. These two, CEDA, silver and gold, are offered by the company I work for. That means Datacenter Dynamics. Also, they had the headquarters in the United Kingdom, and it's delivered for the rest of the world in different places. So this is the specific case of a general wishing as much certifications as they can have. So specifically, let's center on certification for data centers. Uptime Institute was founded in 1993. In that time, they were offering certification only for design documents, but also for constructed facility. So you can see this tier certification, for example, tier 3, for design, but also for facility. In past, they never offered certification about operations. Now they were pushed by these other international institution, and since 2010, they moved to make the certification about the operational sustainability. They applied in a good number of countries. But what it means about talking about tier 1, tier 2, tier 3, and tier 4, remember, tier 1 is the basic capacity in everything, infrastructure, talking about IT systems, the power, and everything, energy, fires. This is the basic. Tier 2 is talking about redundancy in all capacity of components. So it could be for cooling, for power. But really, if you really want a better availability, this is like 1 9, 2 9s, 3 9s, and tier 4 means 4 9s of availability, considering a year. So for tier 3, you must consider tier 2 plus redundancy in all cases. But the start is tier 4. That means your data center must work as a full tolerance. So you can have maintenance as with no interruptions. No? This is, for example, the case of the 2 videos we saw, the data center of the 2 videos we saw. They are related to this, at tier 4, with the fault tolerance of 99.99% That means just some hours a day for failure. Even in this level, we are talking about 52 minutes a year to be out of service. Less is not a tolerance. So that's the idea. Let's see, for example, around the world again, as a United Kingdom headquarters institute, they moved much more in Europe, but also in the rest of the world. So what about the International Computer Room Expert Association? Well, This institution has a headquarter in Mexico, and it was founded in 1999, and they create a standard which is updated every 2 years. Obviously, this industry is very competitive, and it includes everything. So this standard, the 131, with the last version, 2017, this international standard. And well, it's a set of recommendations for best practices mainly. No, they attack obviously electrical installations, the facilities, communications, air conditioning, fire, security, IT governance, and environment. What if you build a data center in a place with a lot of headquarters? Then you have, if you have a specific place, you know, the level of 8 in the scale of headquarters, you have to build data centers for supporting 10 or 11, no, or even 12, as in Japan, for example. So what are the levels created by ICREA? So in this case, they have 5 levels, you know, it's driven by the number of 9s. So the number 5, the level 5, that's what we call the high security, high availability, high security, safety, world-class, quality assurance data center. That's the entire name for the level 5 of ICREA level, with 5 9s. That means a bit more than the Uptime Institute. That was the reason, because Uptime Institute began to offer the operation. In this case, ICREA offers certification about the operation. They do not certify the design or the construction of the facilities. So the both certifications for companies are complementary. Well, I'm at the end of the presentation. Mainly conclusions are from you, but in the final slide, I have to say that this post-Snowden era or age has changed some things, and it's making the infrastructure as a service as something not only to be as not sourcing service. It is a need for the data sovereignty pushed by Germany, that a country need to have their own data centers. That means data centers inside your country. Obviously, sometimes it's not very easy for countries which not too much economic power. About information, the point is it's growing as a madness. Now, imagine 2007, we had 20 exabytes. In 2012, zettabytes. In 2020, it's expected 50 times more. So we're talking, we are in the zettabyte era. The main problem with big data and with data analytics is that around the world, less than 1% of all information is analyzed. So a lot of information has been stored, but you know, we are spending a lot in storage, but analyze it, not too much. Well, with videos and audios is a bit different thing. So it will be a lot of investment in high performance analytics, what we call the big data analytics. So it's a huge business, and it will increase, and we will see how the faces of cloud computing will continue changing with infrastructure as a service. Well, everybody, thank you for attending for this talk between our institutions, IEEE Computer Society, and mainly I want to thank to the Computer Society Turkey chapter, Dr. Fatih and Carrie, for hosting us. I don't know if you have some words to share. Thank you very much. It was my pleasure. Are we on time?
Yes, we are. Do you have a few moments for questions?
Yes, sir.
Okay, there is one question coming from Enes, and this goes back to your slide that had the image of the data centers in Turkey, and Enes would like to know how many data centers are in Izmir, Turkey, if you happen to know that.
Sorry, we are in the, okay, are we checking the Turkey? Yes, Istanbul, yes. Ankara, and Bursa. So sorry, the question is Izmir?
Izmir, Turkey, yes.
Izmir, Turkey. Let me check a specific three.
Three.
So please let me show you. Let me show you. Where can you find? I will out the presentation. I'm sharing still the okay. Let me, in order everybody can check. This is listeners and everybody. If you wish to move to this part, please try to go to this www.datacentermap.com. Are you following me?
Yes,
Again,
it's showing up.
that it's joined, not separated. Here, datacentermap.com. So immediately it will appear as, let's move here. View as a map. Here, I will check. Here, all the countries are listed. We can go to Turkey, 47. You know, they are changing this constantly. And sorry, again, the city was
Izmir, Izmir.
Three. Yes, Izmir. Here we say three.
Oh, okay.
I remember well, but let's see. Let's view specifically Izmir. Let's see where can you find. Okay, here is the address. Eurota Internet Services. Service Liman Budgets. Sorry for my pronunciation. Konak, Turkey. Here is the address. Here you can find the address to visit the place. Here we have Bornova, Turkey. The company is Net Direct IS. And here they are telling you that Inedmart and other companies hosting more than 50,000 websites and with more than 1,500 services. Yes, here. And we have this one else, the Saglayizin Izmir, number 1. Also in Bayraktar, Turkey. So if you enter to this, you will see details and address, and you can ask them to be received. No, so we have 3 companies. So I hope I have answered the question. Please, everybody, if you are interested, www.datacentermap.com, and they are updating the information day by day.
Okay, and
thank you very much for asking.
We have a couple of more questions from Jihan, and this one is regarding the backup energy sources in case of power failure. Is there any time definitions? And how long should a system be able to operate in case of power grid fails, as an example?
Okay, it's immediately. It's in real time. That's the reason, because, for example, if you are a bank, all banks move to tier 4. All banks move to tier 4 or ICRIA 5. That means multi-redundance, not failure, and the change. You mean at least you need 3 different sources of energy. If one fails, immediately all the systems change in real time, because this industry must be better than the industry in the air. The airplanes, as you know, airplanes used to work with what? With Sigma 6 Sigma. Are we having problems?
No, we're good.
No, okay. So, the air, in this case, airplane industry uses 6 Sigma. That means 3.5 failures for each 1 million of opportunities. That means for each 1 million of flies around the world, it's almost secure that you will have 3.5 failures. But well, nobody wished to be in that. Nobody wished to be part of this 3.5. So for data centers, for banks specifically, they must go beyond. So this is very strict if you are in the zone of the ICRIA 5 or tier 5. But this is very expensive. So in this case, not everybody goes to that levels. So some smaller companies go to tier 3 or I create 4. It depends. In Mexico, for example, we have only 2 universities interested in the certification in Tier 1 for their data centers at universities. But, you know, this certification is given year by year, so it's really expensive. Are we okay?
Yes, no, we're fine. The issue, I think, is just with your computer, because you've got me spinning around in circles there.
Oh, yes, yes, perfect.
So the next question is, for the data centers in space, wouldn't the extreme temperature changes as
Yes.
well as the solar instabilities be challenges?
Yes, yes, that's the point. That's the point. I'm working a bit in with people in France, in Grenoble, because they have a specific study group. Because, you know, now the cheaper satellites using electronic coast, no, the low cost, and they say, okay, maybe radiation will impact, but at the end of the day, my satellite will be in functioning for 3 years. So they are trying to use these devices. Obviously, high energy impact their devices, and they can change the data, no? But now we have around the world very well knowledge about satellites. So the idea is now having more than this, just the satellite, and having a container, or even middle of the container. But yes, obviously, yes, you're right. The impact of high energy particles is a mess. It's a problem. The same that we'll have the not only the equipments, but also the humans. So we have to decide. Some companies have and governments have to decide if putting the small data centers, a number of small data centers in space, or having data centers inside Moon or inside Mars. So new generations will see that.
Okay, and I think this will probably be our last question, since we're going long and we don't want to keep you for too long.
No problem for me. I'm happy.
This last question is, I have a question regarding Microsoft Project Nautic, which is an undersea data center. In terms of infrastructure and maintenance cost, is it feasible to build data centers under the sea?
Well, yes, but this is a very specific kind of data centers. And imagine, for example, the idea is, as you saw in the case of the Green Mountain, it will support any change in the sun, not only cyber attacks, also wars. So in many cases, governments are using real bunkers for war, no, even for nuclear war. In some countries, the richest one, some data centers are very deep inside, and they are prepared for having enough resistance against nuclear attacks. No, really bunkers. So the other idea is having data centers inside the sea. This point is for cooling, because as you see before, the amount of energy is really a problem. In some parts in Europe, for example, Google and Facebook offer the hot water to the town. Why? Because the quantity of heat that you have to take away from the data centers is really amazing. So even, for example, in this case, maybe you can remember that Chinese, in the last decades, they moved their ships from China to maybe United States or other countries, moving and having people inside working day by day, or during the 3 blocks, each 8 hours. And they now move inside the ships also data centers. The easy way, the advantage is to have what? The water of the ocean. Obviously, what they have to do is to clean that water. But they could use chillers, and other technologies. And that could be the reason. So people is trying to look any solution in order to reduce the energy spent for removing the heat in data centers.
Okay, very good. Fatih, do you have anything that you would like to say from here?
No, nothing to add. I think it was a great talk, very informative. I think I'll be looking at this URL, datacentermap.com, after we hang up.
Okay, great.
Okay. Well,
Thank you. Well,
thank you very much.
well, thank you very much.
Thank you to all the audience also.
It was great having you guys, and I hope that
Thank
we'll
you.
have.
Thank you, Ignacio.
Thank
you,
you,
Kerry.
Dr. Fatih, and everybody in Turkey. Thank you, Kerry. So have a great day. Thank you very much.
Bye.
Okay, you too.